So they have drawn the circuit with the simplified parameters. So you can see this YIE, these components which I am shading out are already there in your circuit, and additionally I'm exciting this with a source IS parallel to IS. IS is the current source and YS is going to be the input admittance of your current source. And I am considering R parallel to L parallel to C a single load admittance YL. See, when you have many elements in parallel, it's always advisable to find admittance rather than resistance, right? So we always find YL. So I'm considering all the three parallel circuit to be coming under YL. So YL will be equal to R parallel to J omega L parallel to 1 by J omega C. So the feedback here you have a parameter YRE. So this YRE is going to be the feedback parameter. So YRE is going to be the parameter which will connect your input and output. So generally the feedback parameter YRE is usually neglected because it is a complex frequency dependent quantity. So they usually neglect everything. Okay. But for feedback purpose, they neglect everything. And so instead of, so what here also, we will not consider that. So this YRE, this current source, and these two are in parallel. YOE and YL are in parallel. I'm going to simplify these two and make it as YE. So the circuit becomes very simple now. You have an input side, you have IS parallel to IS, then you have this YAE, then you have this Y equivalent. So whatever current entering your amplifier is IN, and whatever current going out of this YAE is denoted as IA. So it is reasonable that for except that some combination of frequency and driving system could result in proper feedback signal. So what they're saying is there is a proper reason for ignoring HRE because only at one particular combination of the frequency and YS there might be a proper feedback signal. So that is going to be unfavorable for amplifiers. So it is which is a highly favorable condition for oscillators. So they are saying there could be a combination of parameters where a feedback signal could come back from the output and go and add with your input. So if that input is, if the feedback signal which is going to add with the input, if it is in phase, then the circuit will start oscillating. We know it is, we said it is positive feedback, right? But if it is going to be out of it, then it is going to be negative feedback. So the amplifier is going to be stable. So what the type of signal is getting added at what point of time? So that will determine the stability of your circuit. And they are saying it will not happen always. There is some frequency combination and the combination of YS which will tend the frequency to be regenerative. Regenerative means it is going to provide a positive feedback. So for that, we are going to analyze what is the input admittance of the circuit. So initially, the input admittance is analyzed, and the possibility of finding out where it becomes unstable is going to be the goal of this topic. So remember, we are going to find out the input impedance or admittance of the amplifier, and we are going to see the conditions where the amplifier becomes an oscillator and what measures can be done to prevent that action taking place, because we want our amplifier to be stable always, and we don't want our amplifier to become an oscillator, thereby going to the state of instability.